Hey guys, welcome back to another video. Here we're going to be looking at this problem. What should be the spring constant K of a spring designed to bring an 1100 kilogram car to rest from a speed of 85 kilometers per hour so that the occupants undergo maximum acceleration of 4 Gs? So we have some units that we need to convert: 85 kilometers per hour into meters per second and 4 Gs into meters per second squared. So 85 kilometers per hour times 1000 gonna give us 85,000 meters per hour, which is going to be, hold on, let me just write this for simplicity purposes. Divide by 3600, it's going to equal 23.61, repeating, meters per second. That's the velocity, all right? Meters per second. Now acceleration is 4 Gs, which is nothing but 4 times the acceleration of gravity, which is just going to be 4 times 9.8, all right? Which is going to be 39.2 meters per second squared. All right, now let's get to our derivation. Now, there's no friction mentioned in this problem at all. All right, so we're just going to completely ignore friction unless it states otherwise. So total energy in is going to equal total energy out. All right, that's the law of conservation of energy. So this is going to be a start point, and this is going to be our end point. The start point is right before the car hits the spring, and the end point is when the car completely stops. So at the beginning, this is going to have a certain kinetic energy. Then here, all the energy is going to be transferred to potential energy spring. All right, now we can use our equations. So negative change in kinetic energy is equal to change in potential energy spring. Let's come over here. So we can just ignore this this negative sign because it's going to cancel out. Half mb squared is going to be equal to half kx squared. Halves cancel out. You get mb squared is going to be equal to kx squared. Divide by x squared, you get k is equal to mv squared over x squared. You have the mass, you have the velocity, but you don't have this. Now, before you click off the video, I need you to understand this. Read the problem extremely carefully. It has a maximum acceleration. It's saying that because as the car compressed the spring further and further, the acceleration is actually going to change. And our kinematics formulas don't work for not uh for acceleration that's not constant. So we're going to use another method. So if you recall from Hooke's law, the net force is going to be equal to, of spring is going to be equal to kx. And we also know from Newton's second law that net force is going to be equal to ma, right? Now just set these two equal to each other. Ma is going to be equal to kx. Let's solve for x. X is going to be equal to ma over k. All right? All right then. Now what we need to do is let's rewrite our equation. Half mv squared is going to be equal to half kx squared. Again, halves cancel out. Mv squared is going to be equal to kx squared. Now let's just substitute in for this. Mv squared is equal to k times ma squared over k squared. If you don't know how I got this, let me just write this here. I just did ma over k whole squared since this quantity is being squared. All right, let's write that again. mb squared is going to be equal to k times ma squared over k squared. All right. Now this is just simplified to mb squared is going to be equal to ma squared over k. All right. Cross multiply, you're going to get k is going to be equal to ma squared over mv squared. Now we have both of these values. Now we can start substituting in, all right? We have our mass, which is just 1100 kilograms. So 1100 times our acceleration, which is 39.2 meters per second squared. And this is all going to be whole squared over mass times velocity squared. Oh, sorry. I wrote the mass wrong. All right, so that's going to be our mass. And now it's mv squared. Remember, we converted from kilometers per hour into meters per second. All right. So 1100 times 23.61 squared. It's going to be equal to 1100 times 39.2, square the quantity. All right, you're going to get pretty big number, 1/8. All right, divided by, let's simplify the denominator. And once we divide these two, you're going to get 3,302.02. All right, so this is going to be our spring constant. Now, I think this problem was kind of difficult because you guys probably tried to use kinematics, and you can't do that since it has a maximum acceleration. So you're gonna need you need to derive x in terms of Newton's second law, and then you can go ahead and find this. And the question wants us to answer in two significant figures. So it's gonna be 3,000. That's our final answer. All right. All right, guys. Thank you for watching. If you liked the video, make sure to drop a like and sub if you haven't